Hello, and welcome to Hands-On Embedded Linux. Our objective in this class is to explore tools and techniques that can help you apply the open source Linux operating system in embedded computing environments. In fact, Linux is probably by now the most popular operating system for embedded development. A 2019 embedded market study from EE Times reported that of the embedded projects that used an operating system, 58% used an open source OS with or without commercial support. Hi, I'm Doug Abbott, your instructor. I've been teaching Linux classes both live and online for something like 20 years now. The course is being presented in a remote live online format. Unlike pre-recorded classes, you have real-time access to me, your instructor, but without travel costs. Let's start by briefly describing what the class is all about. Fundamentally, it's all about applying Linux to embedded computing devices. What kind of devices? Take your pick. Mobile phones, medical instruments, point-of-sale systems, anything that requires a fair amount of computing intelligence. Now, even though this is not an introduction to Linux, we'll start with an overview of Linux and the open source philosophy. Then we'll install a cross-development environment so we can build software for an embedded computer. We'll introduce the Eclipse Integrated Development Environment. We'll use Eclipse to write and debug application programs. Clearly, the Linux kernel is an important part of any Linux system, so we'll look at configuring and building the kernel. Finally, we'll wrap up by examining the Linux initialization process and how we get our final product software onto the target board. Here in more detail are the objectives for the class. First, we'll set up a cross-development environment so we can build programs that run on a target embedded computer. Then we'll use the Eclipse Integrated Development Environment to build and debug applications on the target board. We'll explore multi-threaded and networked applications. We'll configure and build the Linux kernel, showing how it's really easier than you might think. Finally, we'll install a working application on the target board and configure Linux to boot directly into it. In terms of prerequisites, clearly you need to be reasonably proficient with C programming. In the course of the class, you'll write and modify a couple of relatively simple applications. As I said earlier, this is not an introduction to Linux. You should be reasonably familiar with the common shell commands and the Linux file system. The course includes the Embedded Linux Learning Kit, so you'll get hands-on practice writing and debugging programs on a real embedded target. The kit is based on the popular Raspberry Pi 3 single-board computer and includes a peripheral board with common peripherals like LEDs, push buttons, an A to D converter, and a small display. The kit also includes access to an ISO image file with a cross-tool chain, the Eclipse IDE, Linux kernel source code, and sample code. Here's what the main elements of the kit look like. It also included are a power supply, a micro SD card, and a USB to serial converter. Here's a more detailed outline of what we'll be covering in the course of the class. We'll start with an overview of Linux and open source software in general. We'll also review the steps involved in installing Linux on a workstation. We'll look at the K graphical desktop environment. Next, we'll introduce important features of the Linux shell. Then we'll get into the open source Eclipse Integrated Development Environment. We'll use Eclipse to build and debug applications for much of the class. We'll configure the host workstation and power up the target board. At this point, we're ready to start building applications on the workstation and running them on the target board. We'll then use Eclipse to debug in a cross-development environment. We'll also look at a simulation technique that enables initial debugging on the workstation. Then we'll get into multi-threading. Next comes network programming and the notion of embedded web servers. We'll do some simple graphics programming using a frame buffer device driver. Then we'll switch gears from the application level to the kernel level, and we'll look at the process of configuring and building the Linux kernel. Next, we'll look at two very useful tools for embedded development, U-Boot and BusyBox. Finally, we'll look at how to get your fully tested and debugged application into the product and ready to ship. And then we'll wrap it all up with a review. You will, of course, need a workstation with Linux running on it. These are pretty much the minimum requirements. If you'll be using a laptop with a USB to Ethernet port, I would recommend one of these. I've had problems with other USB to Ethernet adapters. If you can dedicate a computer to Linux, so much the better. But as we'll see in the first lesson, you can easily set up a system that runs both Windows and Linux in parallel. Go here for more information.